So for ARP spoofing or poisoning, it can be either or because they're both the same thing. This sort of attack is where an IP address of a computer or device on network is basically changed into being another address with a different MAC address. Now, a MAC address is an actual physical address of a computer. So MAC stands for Media Access Control Address. Just to sort of put it into perspective, if we were to go on to our drawing, so with a MAC address, you will have PCs on a network. They don't want to let me draw. So say we have some PCs on a network and they're connected together by a switch in the middle, something like that. So they might have IP addresses 192.168.1.1, 192.168.1.2.168.1.3. Now, they are the addresses on the network. So when, say, this computer here decides to try and contact it, excuse me, it'll send a message to the switch, and the switch will try and find which address is attached to which port, which it would potentially try this one, realize it's not correct, then try this one. But once it's found this address once, it knows that this address is attached to this port here. So it will always remember that this line is the line to 192.168.1.1. The way it does this is through another address, which is called a MAC address. So there's an IP address, which is this one, and then a MAC will be something, it will have random letters and numbers in it, but it's usually like, A601 2B 2B. It can be anything. I've just made that up. It literally can be anything, so you can't just take this as gospel, but that would be potentially a MAC address. So that would be a MAC address that's associated with that IP address there. And basically it's saying that this port here has that MAC address. So it will always remember that 192.168.1.1 is associated with that address. So it's basically just the actual physical address of it. And these do not change. So these MAC addresses do not change. They're the same if you took the computer out. So if you were to take this computer and put it somewhere completely different on a different network, the IP address might change because it might be 192.168.2.1, say, but the MAC address will stay as that one because the MAC address does not change at all. That stays the same throughout every network. It doesn't change for a physical piece of hardware. I would suggest, if you haven't watched the video on IP addressing, you watch that first, because that will make no sense if you've not watched the very first video. But that is how MAC addresses are associated with IP addresses. Now, when we're talking about ARP spoofing, what you do is you attach a rogue IP address to a known MAC address that's trusted. So, say like a router has a MAC address that's trusted, you could potentially pretend to be that MAC address with a different IP address and then start sending the data to that other IP address instead. Now, this might seem confusing because it's difficult to explain just through a presentation. I have got a demo set up and I will be showing you that momentarily. So essentially what they can do by doing this, attackers, if they pretend to be a trusted machine on the network, people can start sending them data. Obviously, it could be emails or anything like that, or login details, and at that point, obviously they can see everything that's going through. So if they've got like a network sniffer, they could literally see everything that's going in and out of their transmission, because they're pretending to be like, say, a router, and they've got getting all the traffic going to them. So I've got this little section that just basically explains what ARP spoofing is. So ARP is Address Resolution Protocol. It basically just means that an IP address is associated to a MAC address. When we're talking about actually spoofing, it's talking about changing the IP address to the MAC address that's known. So you change the IP address of a MAC address that's already on there. So instead of it being something that's trusted, it changes to something that is not trusted. If you read this and you think, what's a default gateway, by the way? A default gateway is the default route to go basically to either a different network or the internet. So that would usually be a router. So whenever something mentions a default gateway, that's what that is. It's just a router on a network. Now, you might be thinking this is really complicated, like I don't understand what's going on. So I'm going to try and make this a little bit easier by showing you this. So this is a network mockup that I've made, and if you look, we've got one network and a separate network. So this is 192.168.2 network, and this is 192.168.1 network. We've got an attacker who's in red, and he's got a packet sniffer just waiting to see what's going on. And then we have another computer on the network that's probably just trying to get across the internet. So pretend that this router is going across the internet into this server to get a web page. So if we were to click on it and we go on to command prompt, because I've already set this up prior, we might use this software at some point, but pretend this is an actual network running. But if we were to type in in fact, ipconfig/all. So this is the configuration for this PC here. And if you look, that's the physical address, so that's the MAC address associated with it, which I've put underneath there. And we've got a IP address, so that's the normal IP address that it would be on a network. Default gateway we've not set, so that needs setting. So if we just quickly assign a default gateway, and we can see the default gateway is the router, so it would be this address here. So 192.168.1.254. So if we now type in the exact same code again and have a look, we can see that it's accepted the default gateway. So now it thinks that this router is the way out to another network or the internet in certain circumstances. So if we have a look at ARP-A, this shows any addresses that this PC knows. So any IP addresses that's associated with the MAC address, and as you can see, it says no entry found because it's not. We've not learned any IP addresses yet. So I'm going to use something called ping. Ping is just a way of contacting another PC on a network just to check that it's there and you can connect to it. So if we ping 192.168.1.254, which is the router, you can see that we're getting replies from it. So it's reached it, and we've gotten replies from it quite quickly. So it's found the router, and we're getting replies from it. So now if we look at the ARP table, you'll see that we've got 192.168.1.254, which is the IP address, and the physical address of it, which I've put the physical address here underneath it. But if we were to go into this router and also take a look at its MAC address, we can see that that is the actual MAC address. So you can see 0001 C950B901. So if we double check back on this computer again, yeah, we could see that that is the right physical address for it. So it's found that address and it's absolutely fine. It's saying that it can find that address and it's working no problem. So if we were to now go on the web browser and try and contact this web server, because that's a web server that I've set up and got it to work. .1.100. Oops, that shouldn't be 1.100. That should be 2.100. It's my fault. That means that will need changing on there. So I will make mistakes like this, and if we ever use this, we will probably end up changing this at some point, so you can actually use it. So there we go. So I didn't put in a default gateway. That's been the problem. So that needs to be 2.100. Oops. There we go. Let's go back on his PC and try pressing go again. There we go. So now it's come up. So we've got a website. So welcome to HSBC, username, password. So I've set up a little thing that could be like a login for a bank, for example. So they've literally gone onto this website, which is that server there, and they might put in a username, and then the password, something like that, and then press submit. So that will have sent something through. Now, for our attacker that's over here, he won't have seen any of that just yet, because obviously something's just gone through to there. However, if we have a look at him, Fast Ethernet 0 desktop, so 92.168.1.254, so he also has a default gateway. What we can give this person, so the attacker, if he finds out this physical address here, so let's copy it and go back onto this PC. So if we were to give him this MAC address, so essentially he would be pretending now. So we've got this MAC address of this router, so what we're going to do is pretend to be this router now. So instead of having this MAC address, we're going to give it this MAC address instead and try to fool this PC over here into thinking that this is the router. So now if we send a ping command out, ping, I believe, yes it is, so ping minus T 192.168.1.10. So we constantly ping this PC over here. So if we now have a look at this PC over here and we try to go into the web browser again, so let's try and connect to our web browser, so 2.100. So we're still doing okay on that front. However, if we go ARP-A, you can see that this address here has got the same physical address as our router has. But because this computer is constantly sending pings through, we've now poisoned the cache. So it thinks that, let me just put it up, it thinks that this address here, this new one, is the router instead of this one being the router. So if we now try to connect to that web page again, we can see that I've pressed enter and nothing is coming up. And the reason nothing is coming up is because now our new little PC here is picking things up. And if we have a look at our sniffer, we should be able to see things that were sent through. So if we have a look at, there should be a TCP somewhere. Let's have a look. Make this larger so we can have a quick look. So if anybody's wondering what all this data is, it's basically just showing messages that are being sent from this PC here. So it's showing that ICMP messages are coming up, which is error messages saying that there's something not right. But if you look, it's saying that the IP address is 192.168.1.20 and it's contacting 1.10. So it is actually getting through now. And what I'm going to do is I'm just going to stop this. So stop sending replies out now because we don't want it to anymore. We've already got our PC thinking that that one is this one. So if we go back on here just one more time. So if you look, we've stopped pinging it. It puts it back to this original one because this one, this is now not sending out a ping. So this one will constantly have to contact this one saying, I'm the router, I'm the router, I'm the router, and it will constantly basically send traffic to this. But if we have a quick look at our ICMP, again, you can see that this computer here, or this computer here, sorry, was contacting this computer. And essentially, if they set it up correctly, because all I've done is I've set it up just to sniff packets really quickly, you could get things like what they're trying to access and what they're trying to send through. Pardon me. But it doesn't. It depends on what they use. A packet sniffer is not going to see that many things. It'll probably see like the headers and just sort of see where it's going and how big each piece of data is. But they might use something a bit more complex. Maybe something like Kali Linux with. I'm trying to think of a piece of software that uses to get these sort of packets from, but they can analyze packets essentially and find out what was being sent. So basically, ARP poisoning is just pretending to be one thing on a network. So instead of being this router, it thinks it's this as the router. That's how it works. It just poisons this ARP cache. So then it thinks that this is the actual router on the network, not this. But it has to constantly bombard it with messages just to make sure that it's actually getting through. ARP poisoning is a bit of a tricky concept to get down, so I might go through it when I see you in class as well. But if you have any problems with this, just ask me and let me know.